Hi, I'm Niklas from Bitsquid, and in this tutorial I'm going to talk a bit about how we use Lua in the Bitsquid engine. So what is Lua? Lua is a modern, dynamic programming language, scripting language you can call it, with full support for things like first-class functions, continuations. It also supports hot reload of everything, unlike static languages like C++ and Java, which means that you can actually change the code of a running Lua program without problems. When we use Lua, we use a just-in-time compiler called LuaJIT 2.0, which is one of the fastest just-in-time compilers in the business for any language. Which means that when using Lua, you not only get full flexibility, fast iteration times, being able to actually work with your code as the game is running, you also get really good running speeds. So how do we use Lua in the Bitsquid engine? Well, in the Bitsquid engine, Lua is actually the main gameplay programming language. You can write a complete game entirely in Lua without ever needing to touch C++. And you can write any type of game using Lua. So just by changing the Lua code, you can change your game from a first-person medieval game like War of the Roses to a real-time strategy game like Crater. You're not forced to do all your gameplay in Lua. If you want to, you can write some of it in C++, and you can also expose your own C++ function to the Lua API. So that way you can extend Lua with C++ functions where you really need the speed. And in fact, whenever our engine is running, when a game is running, Lua is always also running. And through the console application, you can interact with the Lua in the game. So in the console here, I can type commands like, I can type regular math expressions, and when I type them here, this console will talk to the running game over TCP/IP, evaluate the result, and print it back in the console, which means that this connection also works not only on my local machine, but I can also run it against tablets, consoles, and so on. And you can see that as I type expressions here, I actually get help from the console. It shows me what Lua functions are available. So I can type a math function and get the result back. Now in this particular code that I'm running here, it's one of our sample projects, the physics sample. There is a global table called sample. So if I want to check what's in that global table, I can just type sample here and press return, and I see the contents of the table. And as you can see, there is a Boolean variable in this table called show help, which is currently set to true. So if I want to change that, I can do that as well from this command line here. So I just type sample.showHelp and set that to false. And as you can see, the game reacts immediately. It's actually looking at this variable to determine if it's going to show this help text or not. I set that back to true, and the help text is back. So this way you can interact with your running game program. So how do you build a Lua program to use with the Bitsquid engine? Well, a Lua program is just a collection of Lua files, .lua files that you have in your project, just as you would expect for any Lua program. And you can arrange these files that you like. You can put them in any folders you like, and use subfolders and so on. But you need to somehow tell the game what Lua script it should start by running. And that is something that we call boot script. And you set that in your settings.ini file. That's a basic file that you have in the root of your project folder that sets up some global settings for the project, like things like screen resolution, if you should go to full screen, some render configuration. And you also set this boot script. As you can see here, it says Lua/boot. You always refer to your Lua programs with the full path, as you refer to any other resource in the Bitsquid engine. So this means that when the game started to load this Lua boot file. Now, the way our Lua programs are structured is a bit different from how scripting languages are structured in some other game engines. We don't have a scripting update code for each object in the game. Instead, we have four root callback functions that get called from our game into the Lua code. And those are init, which gets called when your game starts up. So here you can do any necessary initialization of the game that you need to do. We have a corresponding function called shutdown, where you can tear down everything that you set up in init. And we actually always do a complete check for memory leaks. So to have that check working, you must make sure that you shut down everything that you set up in the init function. And then there are two functions that get called during the regular game loop, the update function and the render function. And everything that you need to do in the game, you do in one of these functions. So what are the advantages of this approach of having a few global functions rather than having callbacks on every object, like update callbacks on all your game objects? Well, there are a number of advantages. First of all, this gives you, as a gameplay programmer, full control over the program flow. You always know at which point in the code a particular function is being called. It's not like callbacks can come to you from the outside at random points. It also allows you to handle your object in batch operations, which is much more efficient. So instead of having 100 bullet objects, each with their own update function that gets called from the engine, you now can do all your bullet processing in a single function. And that allows you to do things like road face culling and other batch optimizations that you can perform because you handle a lot of objects of the same type at the same time. Another advantage is that the Lua code becomes much easier to performance measure. So instead of having 100 small update functions that all take a little chunk of time, making your engine die the death of 1,000 cuts, you now can organize your gameplay code into clear systems. So you can have an AI update, and then you can performance measure exactly how much time you're spending in the AI update. And similarly, you could have a bullet update or a player update, and you can easily see where you're spending your time and focus on optimizing those Lua functions. So it's really a much nicer way of working than having lots of small little functions spread out all over the engine. So let's dig in a bit into the code here and see what the code for a typical Lua project would look like. Now, the reason I'm using one of the sample projects for this video is that they are much smaller projects, so it's easier to get a complete grasp over all the Lua code in the project. Now, if we look at the init function here, we see that quite early here we have a test if we're running in the level editor, and this is just to make the drop-in play from the level editor work. So the way that works is that when you're running drop-in play from the level editor, it saves the level to a special file name, double_level editor test. So if we're running from the level editor, we make sure to load this level and run it. Otherwise, we go into the main menu by calling a menu function here, which calls sample set scene menu. This is a object constructor of the menu class, which we have here. So menu is a class that inherits from scene. We have a global class called scene in this project, which is capable of displaying a particular level. So when this object starts up, it calls start on the scene and it sets a particular sky dome. And the way the scene work here is that when start is called here, it sets up a new world. A world is the place where units and other things live. It sets up a viewport, a shading environment, camera, a graphical user interface. And these are the typical things that you set up to have a world that you can run around in, and so on. And then here, let's go back to the boot script, and it sets this menu as the scene in the sample. So in the global sample table, we have a field called scene, which shows current scene. So when we switch scene, we shut down the existing scene, and then we call start on the new scene. We go into the menu. Then, while the game is running, we get this update call. We check for F5 here. If we're running in the level editor, we check for F5 so we can, and if that is pressed while we're running from the level editor, we run this code to drop out of the game and back into editing the level. But this is all to do as well with drop-in play. But it's interesting to note that this code is, these two pieces of code is actually all you need to support drop-in play from the level editor. So if you just add that to your projects, drop-in play will work for you. So if we ignore this level editor stuff, what happens in the update call is that we call update on our current scene. And the same thing for the render call. When we get that from the game, we call render on our current scene. So in the menu here, we have an update call that draws this Bitsquid physics sample menu. If you remember, if I go back here to the menu, it draws this menu, and depending on our selection here, we can actually drop into different levels depending on what we pick in the menu. And in the render callback here, we just set up the shading environment, and then we call render world to render our world. If the user picks one of these options here, we initialize a level object, and that's a different class which is called here. It still inherits from scene, so when we start up the level, we set up the scene, so we get all these things, we get the world, we get the camera, and so on. And then if we have supplied the level here, we load that level. So we run load level to load the level into the world, and then we're up and running for this level. We also initialize the camera controller here, and this is what allows us to run around in the game with our character. And we have an update function as well, because at this point our current scene has switched over to this level class. So when we get the global update call from the game, it will go to here, and this will call update in the level class, which goes into this function. So it will draw this help text. If I go back into the game and jump into the scene here, you see that help text that's being drawn here and here, and it handles those keyboard actions from the help text, and then it calls update on the scene, which updates the world, and in render it renders the world. So this is typically what your typical gameplay script would do. We have a pretty extensive documentation on the Lua API that you can access by clicking this high-level docs button in the Tool Center. It will open a Windows help file where you can find all the classes that we expose in our Lua API with the descriptions of the different functions that are available in each class. So this is a useful resource for getting hold of everything you can do from Lua within the engine. So to round this off, let me show you a bit how you would work with Lua in the Bitsquid engine on a day-to-day basis. In the console here, in addition to typing Lua commands, you also have a Lua menu. And in this menu, for example, you have an option called Rebuild and Reload, what this does is that if you select this option, it will recompile all the Lua scripts in the project and reload them in the engine. So you can go into the Lua code and then make some change. For example, I may change the text F2 here to something like cookie. Save this. Go back into the engine, bring up the console, and if I now select here Rebuild and Reload, it recompiles and reloads the Lua script, and as you can see, F2 here has been changed to cookie. And if you make so this way you can work with your Lua code, you can edit your gameplay code, add functions, do whatever you like, and keep reloading it without ever leaving the game. So you don't have to restart and reload, you can just edit and work iteratively with Lua without ever leaving the game. And if you make a mistake, like let's say I create a string here called test, and I try to add that string to a number. I save, I go back into game here on the console, and I try to run this reset and rebuild and reload Lua code. So you see here now I get an error message that says attempt to perform arithmetic on local A string value, which is not allowed, and helpfully the game has now been automatically paused for me, and this allows me to go back into Lua, fix this error that I just created, save, go back into the game here, and run this rebuild and reload again. And now it reloads the Lua code, and it also automatically unpauses every time you reload the code. So you see that even though I made a mistake and caused an error in Lua, it didn't bring down the game. I can still keep editing and keep working with Lua. We also have an integrated debugger here from in the Lua menu, which I can bring up by selecting Open Debugger. It brings up a debugger. I can open one of the files in the debugger. So I can just type level here to get to the level file. As you can see, there are actually a bunch of other files here in the core folder, and these are actually Lua scripts which are used by our tools. So we actually use Lua to run the tools as well. But to get to the particular file that I want, I can type Lua/level and I get to the project level file. I open that, so now I can put a breakpoint somewhere here. Let's put it in the update function, since that is called every frame. I know that I will hit my breakpoint. As you see, as soon as I set it, I hit the breakpoint immediately. And at this point I can inspect the values, look at my the self object and so on, inspect other values. I can also change the code here. So I can change this cookie text back to F1, and then I can choose continue here to keep running. And as you see, since I made a change to the project, to the code here, it asks me if I want to save and reload these changes before continuing to run. And I want to do that, so I press yes. And if I now close down the debugger, you can see that the cookie text here has been changed back into F1. We actually also have integrated functionality into Sublime Text. So if you install our Sublime Text packages, you will have a Bitsquid menu here under Tools, where you can choose to execute a particular file that you're working on. And the way code works in Lua is that executing a file is actually the same thing as reloading it, as you're rerunning all the function definitions in that file. So another way of changing and working with changing and reloading code is to just edit the code directly here in Sublime Text. Okay, let's change these lines to I want cookie, for example, and then I'll go into the Tools menu here and select Bitsquid, execute entire file. And if I now go back here into the run example, you can see that the text has been changed to I want cookie. So this way you can actually work with Lua, you can rewrite your files, you can add functions, add code, add functionality, make bugs, fix bugs, test values, experiment with things without ever leaving your game, without ever having to restart. And of course, this is a real productivity boost for gameplay programmers, which is why we like working in Lua so much. So that gives you a quick introduction to how to use Lua in Bitsquid. Thanks for me, and we'll hear back soon.